Good morning, and welcome back to the next episode of Making My Game. A couple of fun updates this time. I'll go quickly run the game so you can just see what's changed since last time, and then we'll talk about it a little bit. But I think last time we had movement and viewport stuff all working. So now we're kind of building towards the very first building blocks towards actually having a working roguelike game. So we're back in here, menu's the same. And this is starting to look a bit better, I hope. So the world is no longer hard coded. It's generating with a very simple algorithm, but like a starting point. So you get a procedural level, and obviously we have walls, we have floors. You can still move around and everything works, and we have a line of sight mechanism that works. You can see here, I can see this wall, so it's white, and this wall, I'm aware of it, like I've seen it before, but I don't know what's there, so it's dark. Sorry, I've seen it before, so I know what's there, but I can't see it now, so I show it in dark. And these black tiles back here, we've never seen. This is probably just a block of wall, right? But as I come around this corner and I come up this corridor, you'll see that this all fills in, right? So I come along here, I fill in the corridor, because I look around the corner, I step, it fills in the wall. And if I run around a little bit and zoom out, you'll probably get a better idea of what the level generation looks like. So let's just kind of fill a little block in. Something like that. And we'll zoom out. So the level generation consists of rooms and corridors. So actually, these are all quite piled on top of each other. So it's a little hard to see. You can see there's a rectangle. So that was probably one room. And then you see there's a corridor that's run out this way and off to the side that probably connects to, there's probably a room here and a room here over the top of it. And there's a corridor that will run from this room off to another room. All done in a way to make sure everything ends up connected at the end. So if we go have a quick look then to just show you where that change is happening. I think this all kind of moved around a little bit, I think. But we're at the start of our main loop, so we've not run for a single frame yet. We're setting the world up. We now create grid tiles. So where before grid tile was just a type, it had wall, floor, or player. It's now a type and a visibility. So we can represent those states of unknown, known, and visible. We take that, and now inside of this init grid tiles, what do we do? So first thing we do, we fill the entire grid with walls. That might be unnecessary. I think everything will zero initialize. I think that's the zero value, but I figured like it makes the world very simple to make this self-contained. We generate a bunch of rooms with just rectangles, right? So these are just positions and dimensions. Does a bunch of random stuff, and you'll notice it's currently very dumb. All right, so it's not like it's spreading the rooms out. It doesn't care if rooms overlap. It just plonks a load of rectangles on the map. Then what is this? Oh, okay, so I create all the rooms, and then I iterate over the rooms. That could probably actually be done in one loop, but how it's working. And then we connect the corridors, and the plan was basically we do this so that you're guaranteed to have a connected system, right? So room 1 connects to room 2, connects to room 3, all the way to the end, and then that last room connects to the first room, is what this line is doing. So you form this kind of ring. So in the worst case scenario, there's at least one way you can get around the whole map. And then, yeah, in here, I basically flip a coin to decide whether it goes across and then up, or if it goes up and then across as it moves between rooms. Something in here must set the player position. I'm failing to spot it. Okay, we don't set it in here. We pass it back out. Done. Okay, yeah. So this then returns. I wonder why I did it that way. This function returns you a position that's in the first room. I guess I have it only passing in tiles and not the whole game state. Maybe that's what I was trying to maintain. But so it passes back out a valid player position. So that if we head back to main, we can take that valid player position and we can then... because I need the same value in a couple of places. Okay, yeah, I see what I was thinking. We can then initialize our game stuff all in the one place. And then you can see my comment on this to say that I've hacked this slightly. So we've got a world and it's all initialized to unknown walls. So the game state is kind of started. And then we call player move to put the player on the tile that they're going to start the game at. I assume we move them from somewhere, but where would they be? Yeah, so we basically move them from where they're already stood to where they're already stood, just to trigger all of our visibility updating. So that probably could be tidier, but it's working for now. I don't want to worry about that too much. I wanted to get this working because this is probably the thing I've spent the most time thinking about in between this and the last video. So what do? First thing we do is we go through and we clear the visibility on all the tiles that you could see before, right? So very simply, there's a square around the player of everything you could see. It is a square, so I'm treating diagonals as the same unit of distance as vertical and horizontal. And I think taking that kind of seriously means that, you know, instead of making circles around you, you get squares around you. And I think it makes things easy to reason about because it means your movement works the same as your visibility and everything's simple. We can revisit that if it does end up looking weird. But you can see down here, what do? We check inside of that view radius. And we just set everything. If it was known or visible, we set it to known. And if it was unknown, we do nothing. So we want to leave it as unknown. So this is how we trigger things that we have seen to go back into the unknown state. So things will go from unknown to visible, and then from visible to known. It's the kind of little state machine if you're trying to imagine it. So we clear out the region that you could see last turn, and then we step forward and we do our visibility checking for the region that you could see on this turn. So if you look, the check pos is on R2, so you're moving to this position, plus this thing that's iterating to bounce along this whole thing. And then we say, if you're visible, we set our visibility. Then is visible. I thought it was more complicated than this, actually, looking at this now. What do? I check the grid distance from the check position to the player, where grid distance is that kind of like how many acrosses, how many ups. It's the bigger of those two, so it's how many steps would I have to take to reach it. 0, so the case you can always see and you always know the tile you're stood on, and outside of the player view radius, it's always false. We then do this super cover algorithm. So what this says is I draw a line from the middle of player pos to the middle of check pos, and I get the tiles and the points at which that line enters each tile out of it. So I'll draw a picture in a minute to sort of show off what this is doing. I think it's a little hard to say out loud. We then check along that path of tiles that line touches, and we do some collision detection on it. So there's a bit of guff in here. So we get the entry position, exit position. So we check where does the line enter this tile and where does the line enter the next tile. And if you imagine the line between those two is the line segment that cuts through this tile on the sort of vision path. If the path is a wall, i.e. this tile that the line is cutting through might block vision, we check wall lines. So essentially we're making a little like a little cross hitbox. And if the line passing through this tile intersects with that cross hitbox, then we consider it blocked, which you can see here. So if any of the tiles along the path blocks vision, we stop, return false, you can't see the tile at the end. If we get through all of those checks, then we can return true, and you can see the tile at the end. Obviously, it doesn't matter if the last tile is a wall, right? You can see a wall, you just can't see through a wall. That's why the path check only has to run up to, but not including that last path. Cool. And then that super cover stuff is maybe interesting. The wall check lines you can see in here are making, I guess, like a pair of lines very close to each other, just around the center. Again, I'll draw a picture in a second to show it off. And then some simple stuff that I've just ripped from Wikipedia without too much thought. To work out, basically, it parameterizes the line segments that you're looking at, whether or not they cross, and they're parameterized in T and U. So as T runs from 0 to 1, it goes along one line. As T goes from as U goes from 0 to 1, it runs along the other line. So if you can find valid values for T and U, which, because they're a fraction, you can check by checking if the denominator is 0, there is no value because you can't divide by 0. Assuming that you can find an answer, so there is an intersection, you then just check if that intersection is within the line segment you've defined, and then you have an intersection. I will push all this up with a tags commit as usual, so if you would like to find this and have a more close look at the code, I'll put a link to that in the description. I don't know if the super cover bit is interesting to see. Again, I'll put a link to where I sort of learned this algorithm in the description. I think it's relatively simple, right? You use a little metric in here somewhere, decision. So IX and IY tell you how far along you've actually stepped. And then you have, I guess, like your gradient. So you know how far along the line will have moved. You compare where the next step will put you for both a step across and a step up. And then we decide whether you're going to step across or up, or indeed if it goes perfectly through the corner, so it is a perfect diagonal step on the line, then you go diagonally. You can also see here the first batch of unit tests I've written, because this was squirrely enough that I was like, I want to make sure as I'm writing this, you can't see anything for a long time writing this, that this is doing what I expect it to do. So you start with the easy cases where you're going perfectly horizontally, checking, going both like left to right and right to left, up to down and down to up. And then the website that I learned the algorithm from has a little thing to play with. So you have slightly harder cases where I just checked that it looks like their tool. So I know I've implemented the same thing that they've implemented. So that was quite fun, actually. That was all quite good. One thing to say that you may have clocked is this is taking the player view radius squared order of magnitude steps to do the calculation. And I think there probably are smarter ways to do this that scale like that number linearly. So where am I looking in here? When we check the tiles that are now visible, there's a lot of like redoing work. If you think as you go through here to check the tile above me, I will then redo work when I check the tile two tiles above me. So I think I can make this smarter if it ever becomes a problem. I also think that's probably true of everything that we're going to write. So I'm going to keep plowing on now that it's functional, and just going to make a bit of a mental note if we ever come back and profile and this turns out to be the issue. There are ways we can improve this. I just don't think it's where we want to spend the time right this second. So I was going to draw on this little grid I've set up, to kind of demonstrate what I've got in mind. That app looks kind of rubbish though, doesn't it? So let me have a go at this. So we imagine the player is stood here. Let's see if I can do a better at sign. No, not really. And then let's use, I guess, green, and we'll put arrows. So your visibility is calculated from the middle of this tile to the middle of the tile we're trying to look at. So in the easy case here, you see it goes through no walls, and therefore it's visible. We take a more tricky case. Should you be able to see that tile up there? And so what our algorithm does, we do that super cover calculation, and we go, I can see, maybe we'll use blue. Hang on. Oh my goodness. So what we're going to do is we're going to check that tile because we intersect it, that tile because we intersect it, that tile because it intersects it, that tile, and this tile. And the first steps are all easy, so we get that path. Do I have to look at this tile as well? I guess we do find this tile. And we also get these intersection points. So we get this point, this point, this point. So if you bear with me. Like that. So the open spaces are easy. We can see through them all, no problem. We then check this tile and we go, it's a wall. So the first version of this I wrote, that would be blocking, right? Any line that passes through a wall like that gets blocked. What you find is actually it's very restrictive. So particularly as you're like looking along corridors, our game involves a lot of corridors. You couldn't see this wall. You couldn't see that wall. You couldn't see that square, right? So your vision along this corridor ends up literally being along the corridor and these two next to you. It just felt bad as you were clicking around. So as nice and clean and logical as that felt, it's, I don't know, it's not a good enough sort of thing for us. One option I did consider is I think you could do something like check corner to corner as well. So for each of these, you do something like this instead. And what you say is if any of these are visible, then you can see it. To kind of like work around that sort of clipping. I had a go at that. I didn't particularly like how that was behaving either. I think I might have made a mistake while I was doing it though. Because I think logically, I think that should work better than it did. So, one thing, doing this, there's a lot of stepping and debugging, and you know, it's very easy. You have one condition the wrong way around, suddenly you can see through walls. It's a kind of knotty little chunk to work through. So simplicity, I think, is worth something here. So what I've done instead is I've said, okay, so I've got that line. I can get these intersections very easily because I'm already calculating them essentially inside of the super cover thing. I just need to pass them out. So what we can do then is instead to sort of define hitboxes for these. So if you think in the first version, our hitbox is just a square. So the first version, it's just a square like that. So any line crossing that at all is a hit. The next idea I had was we could just make it diamonds like this, right? And actually probably, maybe saves us in this case. Let's imagine that hit is above halfway and the diamond hitbox comes in here. Then that misses it. We kind of cut that corner and it works. That improved things, but it didn't make it as good as I'd like. Again, mostly looking along corridors and into corners. It was still too restrictive. So what we do now is I draw a pair of lines very close together near the middle of the square. I draw another pair of lines very close together in the other direction. You call this your hit cross. But your hit cross shape will depend on what's around you. So we can be a bit smarter and it can reflect the layout of the map a little bit. So if we have a wall like this that is sort of floating in the air, the hit cross is small in both directions like that. So line of sight will be blocked heading straight through it. But actually it's very lenient line of sight blocking kind of either side of it, right? You can see, like, I'll get my arrow back. If that's the only wall in this direction, you could see this tile, you could see this tile, right? You could probably see everything except for stuff right behind it. And there is going to be a point, like, to the side where it's far enough behind it, but it'll cast like a long, thin shadow, which I think looks like I expect it to. the tricky case with something like that, obviously, is that walls like this should fully block line of sight. So what a wall does is it extends those hitbox lines in the direction of sort of cardinal direction neighbors. The hitbox here will be short. Oh, the line thing will be really short in this direction, and it'll be really short in this direction, but it'll extend all the way down in this direction. Right, so these will form a complete wall along here, but they won't be two blocking in this direction here. So there is no vision across a contiguous block of wall, but there's lenient vision around a corner. So the sort of thing that this allows is, if I go and run the game quickly, you can see into rooms easily. So like here, I'm stood at a corner, and I can see kind of peek along the wall easily, but I can't see around the corner easily, which feels sensible, right? It feels like to know whether this is a wall or if this opens out into a space, I probably should have to step, like come out around the corner so I can see it. Sorry, I'm moving around the mic like an idiot. I probably sounded terrible. But yeah, this is working kind of like I would want it to, right? You can see it kind of, I can see around the corner a little bit, and I can see my line of sight isn't blocked to this tile, which feels right, but it is blocked to this because it'll hit this tile. It's blocked to here because it would hit this tile. Like it's kind of behaving like what feels sensible to me, at least. So I don't know that we can judge it in isolation. I think we need to get some other gameplay logic in to see if we're happy with it, but kind of aesthetically, I think it's working like I want. One other thing to say, vision into corners is a pain. Like, all of these wall collisions makes it kind of hard if you don't do this kind of like stepped back hitbox stuff to actually be able to see that corner unless you get like literally on the diagonal it's on. Whereas this kind of more lenient hitbox lets you see into the corner from a position where you're at a slight angle from it. Which again, I think just seems right. It seems useful without being overly complicated. This splitting business, I don't know if it's necessary. So when I've done it, the thing I was thinking about and slightly concerned with is, so if we look at this guy, his hitbox kind of sits here and there to the edge. The sort of thing that concerned me is what happens if we don't handle our boundary conditions perfectly. And so then for some tile behind this, that works there. I hit perfectly at the point where this one reaches here and this one reaches here. And I'm just doing a check that's like, if these two intersect, then blow up. But obviously I'm doing all of this in floating point math. So it's possible that as things get jostled around, this thing that we're thinking is 0.5 actually ends up being like 0.499999. And this line that's coming through here that should be 0.5 is 0.5000001. And suddenly it decides it's not hitting either. Whether or not that's actually possible, I don't know. But I thought this seemed like the kind of thing that'd be a nightmare to track down later. Whereas at this point, I'm thinking about it, and I think splitting the lines very slightly catches that, because if we have the same position here, this line passes through the middle there. There's multiple points it has to intersect, so they're both deliberately displaced off of 0.5. So you end up with like 0.5, 0.01, 0.000, and 0.499999999, right? Like, which means that those floating point inaccuracies hopefully don't push it like past 0.5 again. And if you're crossing over that 0.5 point, you have to cross both of these to get out of the tile again. So you will guaranteed trigger one, is my thinking. Right, so like if you would hit, maybe it makes sense to draw it bigger. I have a line there and a line there, and that's the kind of like place that our imaginary line would have been. If you would have hit that line there perfectly, imagine I could draw. Oh my goodness. I'll do this. If you would hit this perfectly, you have to have crossed this to get to it, right? Is my thinking, if you're coming from this side. So, I don't know. It does increase the amount of work, but only by like a very small amount. Maths is very cheap, so I don't think that's a worry until we see the frame rate become a problem. Yeah, all to say, lots of rambling. You could probably tell I've tinkered with this a bit and thought about it a little bit, and this is where we've landed. That's how the final thing is currently working. And I think it's quite good. I think it's hopefully gonna work well enough that we don't have to revisit it for like a significant amount of time. We can get on with, I don't know, some other logic, and start getting something that's playable. One thing I do think is worth probably saying, I don't know how well this scales up as we start adding like hundreds of monsters who need to check if things are visible to them. It's possible that we'll have to come up with a simpler sort of visibility algorithm for monsters, particularly monsters you can't see. I think that small errors in the visibility behavior the player sees are very, very noticeable. So it's important that we get the player visibility like bang on. I think small errors in the visibility of monsters that you're directly interacting with is probably very visible, or will lead to counterintuitive gameplay if like you run around behind a wall, but because of a glitch in the visibility logic, the monster can see through that wall to that one tile. You just have no way to know. But monsters that are like 3 floors away from you, but have been activated and so are walking around and are doing things. Like, I don't know. Maybe there's a way that we can come up with something that's a bit cheaper to work out than this. To get like a good enough behavior on them so that they behave predictably and sort of like seemingly intelligently, but without it costing us too much calculation. But that's a problem for another day. We'll have to think. Trying to think if there was anything else I was planning on saying. Let me go just check the README again. Tag comment below. So if you would like to go and poke around in this, feel free. Chunk of stuff of me sort of researching different ways to draw straight lines, basically. In the end, this Red Blob Games was very useful, and I'd recommend. He also, I think, was quite convincing. So when I first thought about this, I was going to use Bresenham line drawing. But he pointed out that the kind of argument I've seen used is, well, Bresenham is the cheapest, fastest, most performant thing because it avoids floating point divisions, and it's all just integer adds and shifts. And he points out, well, this was logic that made perfect sense a long time ago when CPUs worked differently. You should probably profile to check that it's worth all of the extra complexity. So he's talking about just like straight, like a line from point to point. So it's not this. He does cover this super cover thing. Bresenham has a limitation that it only puts one tile in this case. When you're going up like this, it will only put one tile per column. So the line wouldn't look exactly like this. So it probably cut this one out and this one out, which I think actually leads to kind of glitchiness in the ability system. And it's that logic has to be split into 8 quadrants. So if you think like if I've got where am I looking? So if I split like this, in this spot we're going like up and right, but we're going mostly up, so I can put one tile per row. Whereas I'm going this way, I'm going up and right, but I'm going mostly right, so I can put one tile per column, right? And you can imagine that then keeps going all the way around, so you end up having to handle those different cases. And the outcome is not as nice as the super cover thing that we've done, but it's slightly less work. And that Red Blob Games points out you can get a very similar outcome using linear interpolation, and it's like trivial, right? It's way less code and thinking. And floating point is supported directly on hardware, right? So your CPU has floating point sort of processing in it now. So it isn't a given that it will be way slower. So worth a read, that one in particular. yeah, this is me agreeing with him. Maybe worth using one and profiling, or just use the simple one and profile later. I think that's where I've landed. I've picked the thing that makes sense in my head. We'll profile it later if it becomes a problem. Yes, I think that is everything then. So yeah, like I say, I will put the git tag in. I don't think I've made one yet. No, so this will be dev 10. I'll put a link to it in the description. If you have any sort of questions or comments, I'd be happy to hear them below. And I will see you on the next one with the next update. Have a good one.